Hi, welcome to video 10 out of 12 in this DP-600 exam preparation course. Today, we're going to be looking at securing and optimizing semantic models. So this is the second part in our semantic modeling section of the study guide. And as you can see here, we're very close to the end of the course. So we've got 2 more modules after this one. But today, let's focus on semantic modeling again. Specifically, we're going to be looking at implementing dynamic row-level security and object-level security, implementing incremental refresh, implementing performance improvements in queries and report visuals. And to do that, we're going to dive into the use cases for external tools like DAX Studio, Tabular Editor 2, and then we're going to go into a bit more detail about, okay, what can we actually do in terms of improving DAX performance in DAX Studio, and also optimizing semantic models using Tabular Editor. As ever, at the end of this video, I'll be asking you 5 sample questions to test your knowledge of the things that we go over in this part of the study guide. Now, as with the last video, I've left links to really good further learning resources from people that are much more experienced in Power BI development and semantic modeling. So I will caveat this lesson by saying, definitely go and check out the further learning resources by MVPs, Microsoft MVPs for the Power BI side. A lot of this content is Power BI and also third-party tools that connect to Power BI as well. So let's start by looking at dynamic row-level security. So in general, when we talk about row-level security, we're talking about restricting who can see what data at the row level in specific tables in a Power BI report. Now, dynamic row-level security is kind of an extension to row-level security by applying row-level security using the usable principal name. Now, there are other information functions that we can use, but user principal name basically gives us the email address of the logged in user. So when the user logs into the Power BI service, then behind the scenes, we're going to get access to their email address, and we can use that to apply filters to the data in our Power BI report so that that user only sees the information that you have configured that they should be seeing. Now, you can configure row-level security in the semantic model, the data warehouse, and the T-SQL endpoint of the Lakehouse in Fabric. But if you're using direct lake mode, then you want to be configuring row-level security in the semantic model. Otherwise, you're going to be falling back to direct query mode. And in general, the whole one security model in Fabric is still kind of under construction. So I definitely recommend, where we are currently, I would recommend just using the conventional semantic model row-level security. Now, one thing to bear in mind is that row-level security only really works when the users that you're trying to give row-level security to have viewer permissions in a particular workspace. So if they have more than viewer, so admin or member or contributor, technically this row-level security is not going to be enforced because they'll have lots of other ways to access that data. So that's one thing to bear in mind. There need to be viewers in the workspace, your users or your viewers of reports. So at a high level, these are the steps that are required to implement row-level security. So the steps for implementing row-level security in Power BI Desktop, well, first we're going to have to create a role. Now, after you've created a role, you want to select the table that you want to apply row-level security to. You're going to enter a table filter, DAX expression, to configure when and who the row-level security is applied to. And we're going to validate that row-level security has been applied correctly. Now, as well as row-level security, we can also apply object-level security to our semantic models. But the way that we're going to be doing that is different, because object-level security can only be configured via third-party tools such as Tabular Editor. And when we talk about object-level security, what we're talking about is restricting access to a particular table in a semantic model or a specific column. So you might have a sensitive column within your Power BI report and you want to restrict who can see that particular column of data in your semantic model. As I mentioned, to configure object-level security, you need to use an external tool such as Tabular Editor. And similarly to row-level security, object-level security only restricts data access for users with viewer permissions. So we can't give them admin, member, or contributor roles in a workspace. Now, the high-level steps to implement object-level security in Tabular Editor, well, again, we're going to need to start by creating a role in Power BI Desktop, or you can also create it in Tabular Editor as well. Then within Tabular Editor, you're going to want to find the role that you've created, click on the table properties for that role, set the permissions for the particular table that you want to apply object-level security on, set that permission to either none or read. Okay, so obviously none will be if you don't want to give them access to that table, and read will be if you do want to give them access to that table. Similarly, we can do the same for a particular column as well. Then we're going to be wanting to publish the report to the service and add the people and groups to the particular role in the service. Next, we're going to talk about incremental refresh in Power BI. Now, one thing to bear in mind here is that incremental refresh is a developing field in the world of Fabric, but for the purposes of this exam, I think what they are looking for is incremental refresh, which is a feature in Power BI, not talking about incremental refresh in data flow Gen 2s or data pipelines or anything like that. So I think we're focused here on the specific feature within Power BI called incremental refresh. And typically this is used on large fact tables because incremental refresh allows you to pull in only the data that is changed within a given range, right? So perhaps in the last 24 hours or the last hour, you might only want to bring in the new data that's changed within that period, rather than, loading in all the data that's in that source database. And obviously that's going to have many different benefits if we can do this incrementally rather than all in one. For starters, we're going to need fewer refreshes. The refreshes are going to be a lot quicker because you're only pulling in what's new. Your resource consumption could be lower as well, because again, you're only bringing in what's changed. You're not bringing in everything every time. Now, the refreshes can be more reliable because rather than pulling in hundreds of thousands or millions of rows every time you refresh the data set, this could create open connections that are going to run really long on your database and have the potential to be timed out as well. Obviously, when you move to an incremental refresh, that problem is likely to go away because your refresh is going to be a lot quicker. As I mentioned, currently incremental refresh is only possible within the Power BI side. So they are working on incremental refresh features for ETL items, like data factory items, like the data flow Gen 2 and the data pipeline. But for the purposes of this exam, currently, when we talk about incremental refresh, we're talking about Power BI. And incremental refresh in Power BI is available for Power BI premium licenses only, so PPU or premium capacity subscriptions. And the incremental refresh policies are defined within Power BI Desktop. So let's just have a look at how we can implement incremental refresh. So it starts by creating two parameters called range start and range end. And they must be called range start and range end. These are reserved keywords for these parameters. And then in your Power Query, you're going to be wanting to apply some custom date filters to filter the data based on that table's date column to keep only the range between the range start and the range end. Then you're going to want to find your incremental refresh policy. And this is what this looks like. You're going to select the table. You're going to set your import and refresh ranges. And there's a few optional settings there, like only refreshing on complete days and detecting data changes as well. And then you're going to review and apply your policy. And then when you publish your report into the service, that's when your incremental refresh is going to kick in based on the policy that you've set and the range that you've set. So next, we're going to switch our attention and we're going to talk about semantic model performance. And whenever we talk about performance of anything really, it's useful to think of it in two steps. Number one is around monitoring and observation and gathering data about what's happening in our semantic model in this case. And then we want to talk about optimization. So once we understand what's going wrong, how can we optimize it to improve performance ultimately? So within Power BI and the external tools that you can connect to Power BI, there's quite a few different ways that you can monitor semantic model performance. On this slide, we'll just do a high level summary of all of them before digging into each of them in a bit more detail. So when we're talking about Power Query performance, there's a tool called the Query Analyzer tool. When we're talking about analyzing the visual and query performance, well, we can use the Performance Analyzer in Power BI Desktop. We can also export that data into other tools like DAX Studio as well for a bit more fine-grained analysis. We'll take a look at that shortly. So when we're talking about DAX performance, we can again use DAX Studio. We can bring in data from Performance Analyzer. We can also use things like traces to monitor all of the different events, both on the client side and on the server side as well. And for semantic model performance, we can use things like the Best Practice Analyzer, which is a tool within Tabular Editor. So for the purposes of the exam, you're going to need a bit of a knowledge about what you can do in Power BI Desktop, the limits of performance analysis in Power BI Desktop, and then knowing when to switch to tools like DAX Studio and Tabular Editor as well, when you want a bit more advanced analysis or deeper diving into the things that are going wrong in your DAX and your semantic models. Let's take a look at these three in a bit more detail. So first let's look at DAX Studio. So one of the core use cases that we can use DAX Studio for is loading the Power BI Performance Analyzer data in DAX Studio for further analysis. So within Power BI, we can record different actions when we're using the report, like clicking on different filters, refreshing different pages, and it's going to log the query time and the visual load time for every visual on a specific page. But the UI in Power BI for analyzing this performance analyzer data is a little bit limited. So what we can actually do is export that data and we can import it into DAX Studio for a bit of a deeper dive analysis on that. We get better filtering and sorting than in Power BI Desktop. And you can also view the queries behind each visual load. Now, since Power BI has introduced the DAX query view, this has become a bit of a less of an advantage for DAX Studio, because now you can also run the underlying DAX query for a specific visual within the DAX query view in Power BI Desktop, but something to bear in mind. Another really core use case of DAX Studio is using the view metrics to look at the VertiPaq Analyzer. So the VertiPaq is the engine, the analysis services engine that basically Power BI runs on. And so we can analyze what's going on in there using this view metrics. We can take a look at table and column sizes, and obviously the size of your table and your column has a really big impact on performance, right? And then we can start to look a bit deeper into reasons why things might be slow, like the cardinality of a column, the different data types that you're using for a specific column, and much, much more. We can also use the VertiPaq Analyzer to look for referential integrity violations. And what we mean by that is a mismatch in the unique keys on two sides of a relationship. There's lots more information in the VertiPaq Analyzer. For the purposes of the exam, I think it's good just to have a look at the VertiPaq Analyzer, understand what you can do there, and the insights that you can gather from that. Another really useful feature in DAX Studio is the trace analysis. So for trace analysis, there's three traces we need to be aware of. The all queries trace is going to capture different query events from client-side tools such as Power BI Desktop. So this is the only one of these traces that's going to be able to capture both on the client side and on the server side your queries as well. The query plan trace there is only really going to capture the query plan trace events from the analysis services tabular server, right? So if you're using the DAX editor within DAX Studio and you're using that to run queries and kind of analyze their performance, that's where you're going to be using the query plan, because it's going to give you the plan of that specific query on the analysis services engine. And the server timing trace is going to give us the query timing from a server perspective. So next, let's switch over to Tabular Editor and look at some of the use cases that we might want to be using Tabular Editor for. And the main one when it comes to optimizing semantic model performance is the Best Practice Analyzer. And this is a tool that basically performs a scan of your semantic model and it checks it for common issues. Now there's a list of rules that can be downloaded from GitHub, and you can also create your own custom rules as well, but there's a predefined list of rules that you can download from GitHub, and they're organized into these categories. We have ones that talk about performance, ones that talk about your actual DAX expressions that you're using, error prevention, formatting, and maintenance. So these are different categories of those rules in the Best Practice Analyzer rule set. Now these checks can also be run from the Tabular Editor CLI as part of a CI/CD process. So when you deploy a semantic model from a development environment to a testing environment, you might want to run the Best Practice Analyzer rule sets against your semantic model to give you an automated way of analyzing the quality of that model, to surface any particular errors that you might get with that model, and things you need to be aware of from a quality and maintenance perspective in that model. So I've left this use cases for DAX Studio and Tabular Editor at the end here, just to kind of review everything we've talked about when it comes to DAX Studio and Tabular Editor. So on the DAX Studio side, we're going to be wanting to use DAX Studio when we want to write and execute and debug DAX queries. But they do actually need to be manually copied over to Power BI Desktop, as DAX Studio is read-only. Now, since, as I mentioned previously, Power BI Desktop now has the DAX query view, you can actually write and execute DAX queries and view the results similarly to how you can do in DAX Studio, but that's a relatively new feature that didn't used to exist. in Power BI. We can use the VertiPaq Analyzer to understand the size of your semantic model, as well as individual tables and columns within the model. We can bring Power BI Desktop Performance Analyzer data into DAX Studio to analyze it further, and we can use those trace analysis functionalities to analyze query events, both on the client side and the server side, depending on the trace that you select. And when we're talking about the use cases for Tabular Editor, we're going to be able to quickly edit data models, so we can create measures, perspectives, calculation groups from the DAX editor within Tabular Editor, and we can publish them directly into the semantic model. So that's a bit of a distinction between the functionalities of Tabular Editor and DAX Studio. In Tabular Editor, we can actually update our semantic models in the tool itself. There's also functionality for automating repetitive tasks using scripting. And as we've mentioned, we can incorporate DevOps into the kind of tabular model lifecycle using that CI/CD functionality in the Tabular Editor CLI. And we can use the best practice analyzer to identify common issues in your Power BI semantic model. Finally, a good use case for Tabular Editor is if you want to implement object level security. As we mentioned before, that's not possible currently within Power BI Desktop. So if you want to be defining object level security, that's going to be done in Tabular Editor. Okay, we've covered a lot of ground again there. So let's just wrap up this video with some practice questions to test your knowledge of this section of the exam. Question 1. Your goal is to analyze performance analyzer data in DAX Studio to find the visual in your report with the longest total load time. Put the following steps in the correct order to achieve this. So what you've got here is 5 steps in a process. Your goal is to reorder this list so that it makes sense for this particular goal that we're trying to do, analyzing performance analyzer data in DAX Studio. So take a moment here, get a bit of paper, maybe write these down in the correct order, and I'll show you the answer shortly. So the answer here is like this. So first, we're going to be starting a recording in Power BI Performance Analyzer. We need to actually record it in Power BI to begin with. Then you're going to be wanting to click refresh visuals just to update the visuals on the page, or you can interact with the report as well if that's what you want to be analyzing. Then clicking stop recording. Then we can export that performance data JSON and then import it into DAX Studio. Then we can go over to the Power BI Performance tab and sort by the total milliseconds descending to find the longest refresh time for a particular visual on the page. Question 2. You want to use the best practice analyzer tool within Tabular Editor to assess your DAX performance. Which of the following severity codes for best practice analyzer rule violations indicates an error? Is it A, level 0, B, level 1, C, level 2 and above, D, level 2, E, level 3 and above? So the answer here is level 3 and above. So in the best practice analyzer within Tabular Editor, we have many different levels of severity of the different rule violations. Level 1 is just for information only. A level 2 is a warning, and level 3 and above is an error. So level 3 and above, E, is the correct answer to this question. Question 3, when implementing dynamic row level security, which information function should you use to filter the data in a specific table based on the logged in user's email address? Is it A, user, B, user object ID, C, user email, D, user principal name, or E, username? So the answer here is D, user principal name. So as you recall, when we're talking about dynamic row level security, and specifically in the question is talking about using the logged in user's email address, and the information function to give us that is the user principal name. Now the user function doesn't exist. The user object ID and the username does exist as information functions in DAX, but these are not the correct answer. They won't give us the email address. The username will just give you the domain and the user's name rather than the actual email address. And user email C is also incorrect. That one is made up. So that's not what the function is called. It's user principal name D. Question 4. In DAX Studio, which of the following records queries that are generated by a client tool like Power BI Desktop? A, query plan trace, B, SQL profiler, C, all queries trace, D, server timings trace, or E, the VertiPaq Analyzer. So the answer here is C, the all queries trace. So the clue in the question here was talking about the client tool and recording queries that are generated specifically within the client tool itself, within Power BI Desktop. So the all queries trace is the only one that's going to give you that information. The VertiPaq Analyzer, well, that's just going to analyze things like referential integrity and the sizing of different tables and columns within your semantic model, not necessarily the load time directly within the client tool Power BI. And the SQL profiler, the server timings, and the query plan, these are all kind of server-side back-end tools. They're not going to give you information about queries generated in Power BI. So the answer here is C, the all queries trace. Question 5. The first step in implementing incremental refresh in Power BI is to A, add a range start and a range end column to your dataset. B, add refresh start and refresh end parameters to your Power BI desktop project. C, add a refresh start and a refresh end column to your dataset. Or add range start and range end parameters to your Power BI desktop project. So the answer here is D, adding range start and range end parameters to your Power BI desktop project. Now, as we mentioned previously, range start and range end, they're reserved keywords when we're talking about parameters. So you do need to specify when you're adding in these parameters, should be range start and range end. Answers A and C talk about adding columns to your data set. That's not going to do anything, or at least anything useful when it comes to incremental refresh. We need those as parameters because we're going to use those to filter date column in the table that you're interested in. So we're going to use those parameters to filter that table. And as I mentioned previously, B is wrong because we're using refresh start and refresh end rather than range start and range end. We need to be specific when we're using incremental refresh to be using range start and range end. Congratulations, you've now completed the first 3 sections of the exam study guide. We only have 2 quite short sections to go. So make sure you click here to join me in the next video where we'll be looking at exploratory analytics in a bit more detail. See you there.